how many 1 by 4 demultiplexers are required in order to implement 1 by 8 demultiplexers, right? What is the solution? We can simply define it as 3 more, right? Because in the previous class we have seen, if you would like to implement m by 1 mux in terms of n by 1 mux, you have to apply the formula called log m to the base n. I think we derived this one, right? This is what you can call it as number of levels, right? For this, if you are going to perform some value of k equal to 1 to log m to the base n, you will get number of multiplexers are required, right? Here just make it inverse, right? So because I can say that demultiplexer is just an inverse of mux, the same formula it will apply here. Okay, fine. So you will get the same formula only, right? Now, so guys, can, for example, if I would like to implement 1 by 8 DeMUX with the help of 1 by 4 DeMUX. How can we do that? Let us take how many outputs we required. We required 4 outputs. Right? Assume that this is y0, y1, y2 and y3, right? Remaining 4 outputs you are going to get from one more 1 by 4 DeMUX. This is 1 by 4 DeMUX. This will be y4, y5, y6 and y7. And for this, how many select lines are there? Basically S1 and S2, right? 2 select lines are there, and you are going to have 1 input line each, right? Now, can I say that this inputs you got from another 1 by 4 mux? Can I do it? Yes. The remaining 2 I am going to make them as zeros. Right? Now I can make it the another kind of thing as S2, right? Now you can get like this. You are going to give the input as I. So based on this, you are going to get the circuit will be activated, right? As it is 1 by 4, how many inputs select lines should be there? 2 select lines should be there, and these are inactivated by myself. This is the way you can able to implement a 1 by 8 demultiplexer with 1 by 4 demultiplexer, right? Yes, guys. So instead of this, instead of the respect to 1 by 4 DeMUX, can I able to use only 1 by 2 DeMUX? Yes, we can do, right? So I am just making redraw. This will be 1 by 2 demultiplexer I can able to simply use, right? Because I require only 2 outputs. Those 2 outputs, one will be given to 1 by 4 demultiplexer, and this input will be given to 1 by 4 demultiplexer. These are going to ranging from y0 to y3, and this ranging from y4 to y7. Sorry, this should be y0, y1, y2, y3. Okay, y4, y5, y6, y7. Right? Yes, this way. And the select lines are like S1, S0, and here it will be S2. This way also you can able to, right? So means the number of gates, if it is the number of multiplexers, if it is purely 1 by 4, here you require compulsory 3 multiplexers are required. Similarly, if you would like to implement, the question is, if you would like to implement 1 by 8 DeMUX using 1 by 2 DeMUX, how many 1 by 2 DeMUX are required here for you? Basically, you required 7, because it's just kind of opposite to the multiplexer, right? As usual. And if you are able to observe here, I will try to modify something. Instead of representing my diagram like this, what I will do now, I will try to do it with the basic gates. Can I do it with the basic gates? If you are able to observe, let me take this as 1 by 4 DeMUX, and this will be also 1 by 4 DeMUX, right? Guys, you know, for each and every DeMUX, there will be a kind of enablers. Right? So here I am going to make this enabler as positive side, and I am going to make here as not, and I will connect like this, and the inputs I will pass directly like this. Input I will pass like this. Then you are going to get here y0 2. This will be only 4 lines, y0 to y0 y3, and this will be from y4 to y7, and there will be 2 select lines. One is s2, another one is s1, another one is s0. Right now, try to observe if enabler is on. If enabler is on, what are the meaning of S1? First circuit is deactivated and second circuit is activated. If enabler is 1, if enabler is 0, first circuit is activated, second circuit is deactivated. Like this you can able, right? Meaning that I can able to control the above 4 lines as well as below 4 lines. So I can make it as also S2. This is also another way of representation of 1/8 DeMUX using 1/4 DeMUX. Okay, fine. So we are at how to construct 1/8 DeMUX using 1/2 demultiplexer, right? So you know you require total of 7, right? So basically if you would like to have 8 outputs, you need 4 1/2 demultiplexers. This you can able to understand, right? This is 1/2, 1/2, and 1/2, 1/2, as these are going to produce y0 y1, y2 y3, y4 y5, y6, and y7, and all are going to have one line as input, right? Because of this as a kind of demultiplexer, right? And now these both inputs I will get from one more demultiplexer, that is 1/2, and it is going to have one more input. Similarly, for this the inputs I am going to get it from 1/2 demultiplexer, right? Now similarly these two will be connected by like this. This is my final input, right? From this your circuit is going to be operated 1/2. Yes, here you may get question, right? So here as these are all demultiplexers, you have select lines, right? So select lines, like if I am saying that this is S2, and this will be connected by S1 value, and these are all will be connected by S0. So all will be connected by S0. You are going to get the respective answer. See, observe. If I am going to give S2, S1, S0 value as 1, 1, 0. So you have to select the line Y6. Am I right? You have to select the line Y6, right? So make sure check. So S2 is 1. So input is 1 here, I here. I will be, when you are going to have 1 as input, out of these, which one is selected? This one. 1. And from this here, S1 is input. What is S1? Again 1. So 1 will be selected. This one will be selected. From this, the input is 0. Input is 0. When input is 0, this will be connected. So you are going to get finally Y6 as input output. Right? So as both are safe, I can say that this is perfectly correct. Right? So this way you can able to implement any kind of demultiplexer with the help of lower level demultiplexers. Right? Yes, correct. So basically what you are observing, what you are able to observe, if I am going to have certain input like I, that input, if I would like to distribute it to multiple people like y0, y1, y2, y3, y4, y5, y6, y7, I can able to use the demultiplexers. So basically the advantage of demultiplexer is, which is meant for the purpose of data distribution, right? And one more thing is, we can be able to define it as for the purpose of routing. Routing means what? How your connection should be there, right? So to get the value of y6, you have to compulsory move in this particular path. So routing should be done. This is what, right? This is the advantage of demultiplexer. Right?